All right, adding and subtracting radicals. So a big idea here is you can add or combine radicals when they have the same value underneath the radical. So in this case, they have the same radicand. All right, so in order to do it, it's kind of like combining like terms. So you're looking for the same value underneath the radical symbol or the radical sign. In this case, you need the same radicand. So if you have the square root of 5 plus 2 times the square root of 5, you can combine those because they have the same value there. If they're different values, you cannot combine them. So here we're looking at determining the simplified form of each expression. So in this example, we'll notice here that underneath the radical, you've got 5x and 5x. Since that's the case, we can treat these kind of like a variable, and we're going to keep them as the square root of 5x, but then we're going to take the 3 and subtract 2 from it. So 3 minus 2 in this case is going to give us 1, so we end up with 1 square root of 5x. That is our simplified form. We're going to do the same thing in B, but as we look at this, we notice that we have different radicands. Different values under your radical, so that means we're not going to be able to combine these. So that means the answer just stays the way it is. 6x squared, square root of 7, plus 4x, square root of 5. In the third one, we've got 7xy underneath the radical, and then we've got 7xy. But pay very close attention. Your index in this case is different for these two. Since the indexes are different, we can't combine these. It wasn't really an issue in the first two problems, but now we also have to pay attention to the indexes. So in this problem, it remains the way it was because the indexes are different. So here, let's go ahead and try 2 more examples. So for the first one, we've got 7 cube root of 5 minus 4 square root of 5. Different indexes means we're not going to be able to simplify this. So our answer as it was is the most simplified form. For B, we have the same square. We're taking the square root. In this case, we're taking the square root of xy in both quantities. So we can bring together the 3x plus the 4x. And then we're going to leave the value under the radical alone. And so here we've got 7x square root of xy. So sometimes it becomes necessary to simplify your radicals in order to see if they will have like radicals. And so when we're trying to simplify things, we're going to simplify each radical separately and then see what combines from there. So in this case, the square root of 12, I know can be broken apart into the square root of 4, the square root of 3, which when simplified becomes 2 square root of 3. Then the square root of 75 can be broken apart into the square root of 25 and the square root of 3. So that becomes 5 square root of 3. We'll bring the addition sign with it. And then we've got minus square root of 3, which just stays the way it is. So minus square root of 3. So in this case, all of these values have the same radical. So we're going to take 2 plus 5 minus 1, and then square root of 3. So that's 2 plus 5 is 7, minus 1 is 6. So 6 square root of 3 is our simplified form. So here we have the cube root of 250 plus the cube root of 54 plus the cube root of 16. First step here is to go in and simplify this, and so we're going to try to pull out perfect cubes. So for 250, I can break this apart into the cube root of 125 and the cube root of 2. I know that the cube root of 125 is just, in this case, 5. So this is 5 times the cube root of 2. Then I do the same thing for cube root of 54. This is going to break apart into, let's see, the cube root of 27 and the cube root of 2. Cube root of 27 in this case is going to be 3. So 3 cube root of 2. And then the cube root of 16 in this case It's going to break apart into the cube root of 8 and the cube root of 2. Cube root of 8 is just 2, so this is 2. Cube root of 2. There should be a subtraction sign here because there's one here. And so now we're looking at the fact that we have the same radical all the way across. It's the cube root of 2. So we're just going to take the 5 plus the 3 minus the 2. And then cube root of 2. And then we simplify that. 5 plus 3 is 8, minus 2 is 6. So 6 cube root of 2. So now to connect this with adding and subtracting radicals, we can then go back and look at multiplying radicals, or in this case, binomial radical expressions. And in order to do that, we're going to use FOIL or crab claw, but then we're going to use our addition subtraction properties in order to bring them together and simplify. So for this one, FOIL tells us first, so 4 times 5 is 20. And outer, 4 times 4 squared root of 2 becomes 16 square root of 2. And then inner becomes 2 square root of 2 times 5 is 10 square root of 2. And then 2 square root of 2 times 4 square root of 2, that's going to become 8 square root of 4. And so now we just want to simplify. We should recognize we have like terms here. So we're going to bring those together. Square root of 4 is just 2, so we're going to multiply those together. And so at this point, we've got 20 plus 26 square root of 2 plus 16. We still have like terms here and here, so we're going to bring those together. So 36 plus 26 square root of 2 is our answer. Let's do the same thing in B. We're going to take 3 times 5, so that becomes 15. We've got 3 times the square root of 7, so that's 3 square root of 7. We've got negative square root of 7 times 5, so it's negative 5 square root of 7. And then negative square root of 7 times square root of 7, that's going to be minus square root of 49. So now we're going to simplify some things. We've got like terms again, or like radicals. We know that the square root of 49 is just 7. So we clean this up. We've got 15 minus 2 square root of 7 minus 7. We still have like terms here, so we'll go ahead and clean those up. So we have 8 minus 2 square root of 7. All right, one more of the same type. We're going to go ahead and use, in this case, FOIL one more time. So we'll go ahead and do this run real quick. 2 times 3 is 6. 3 times 4, that gives us 12, square root of 5. 2 square root of 5 times 2, that's 4 square root of 5. And then 2 square root of 5 times 4 square root of 5, that's going to be 8 square root of 25. We just want to simplify, so we've got like terms here. This becomes 5, so we multiply those. So 6 plus 16 square root of 5 plus 40. Bring together your like terms. 46 plus 16 square root of 5. So here we're going to look at multiplying, in this case, conjugates. And so we talked about conjugates in previous sections, and so we should recognize some things are going to cancel out here. And so in this case, this is the same. So let's just go ahead and approach it the same way we were just doing the problems using, in this case, FOIL. So 5 times 5, you get 25. 5 times square root of 7, that becomes 5 square root of 7. Negative square root of 7 times 5 becomes negative 5 square root of 7. And then negative square root of 7 times square root of 7 becomes negative square root of 49. And in this case, we should notice that because we're multiplying conjugates, these are going to cancel out. And then the square root of 49 is just 7. So we've got 25 minus 7. In this case, we're going to take 25 minus 7, and we're going to get 18 as our answer. Go ahead and give these two a try on your own. Same thing we've been doing, and then unpause the video when you want to see the answer. So in the case of question A, you should have gotten 24. In the case of question B, you should have gotten 1. So here we want to talk about rationalizing the denominator. To rationalize the denominator, we're going to multiply the top and bottom by the conjugate of the denominator. So in this case, we're multiplying by the square root of 5 plus the square root of 2. And we'll do the same thing up here. And we're multiplying. So across the top, we're essentially just distributing. So we can go ahead and distribute this value. So that's going to be 3 square root of 10. And then plus 3 square root of 4. On the bottom, however, we've got to use FOIL, but we know with multiplying by the conjugate, we're going to see the middle cancel out. So a lot of this we can do mentally now. So in the beginning, we've got square root of 5 times the square root of 5 is going to be the square root of 25. The middle should cancel out, so we're worried about the back end. So that would be minus the square root of 4. I know that the middle terms are going to cancel out, so I'm not including them here. And so, but if you're confused, we'll go ahead and write it out real quick. All I did was FOIL this, but I know for a fact that the middle is going to cancel out. So like this becomes the square root of 25, and then you've got plus the square root of 10 minus the square root of 10, and then minus the square root of 4. So I'm just skipping this step because I know it's going to cancel out. All right, so back to the problem. This simplifies down to 5. This simplifies down to 2. This doesn't simplify yet, but this simplifies down to 2. And so in this case, we're going to see across the top, we now have 3 square root of 10 plus 2, or sorry, not 2, plus 2 times 3, which would be plus 6, over 5 minus 2, which would be 3. Well, notice here everything is divisible by 3, so we can simplify those. And so our final answer is going to become square root of 10 plus 2. All right, let's look at another example. All right, we'll go with question A. We'll do question A together, and I'll let you do question B on your own. So you've got 2 square root of 7, square root of 3 minus the square root of 5. Multiplying by the conjugate, in this case, it's going to be the square root of 3 plus the square root of 5 over the square root of 3 plus the square root of 5. So in this case, we're going to distribute this like we did before. I'm just going to write it. I'll write it down here. So we've got 2 square root of 21 plus 2 square root of 35. And then on the bottom, I know because it's the conjugate, the middle is going to cancel. So I've got square root of 9 minus the square root of 25. In this case, I know this is 3. This is 5. 21, the square root of 21 doesn't simplify. Square root of 35 doesn't simplify in this case. So our answer is looking like it's going to be 2 square root of 21 plus 2 square root of 35 over negative 2. Well, we can simplify this because these are divisible by 2. And so we've got negative square root of 21 minus the square root of 35. We can go ahead and look at B together. So we're going to go ahead and multiply by the conjugate. In this case, it's 3 plus the square root of 6 over 3 plus the square root of 6. So across the top, we're going to get 12x plus 4x square root of 6. On the bottom, we know the middle's going to cancel, so we get 9 minus the square root of 36. Square root of 36 we know is going to be 6. So 9 minus 6 we should recognize as just being 3. So if we write this out, we've got 12x plus 4x square root of 6 over 3. And since 3 doesn't go evenly into 4, or 4x in this case, we're going to leave it just like this. We only talked about 2 examples for adding, or in this case, adding radicals, where you have to simplify first. So let's just take a quick look at 2 extra problems here. So in the first problem I have 5 square root of 3 plus the square root of 12. They're not like radicals, but I know that I can break this apart into the square root of 4 and the square root of 3. So this becomes 2 square root of 3, and then we bring the 5 square root of 3 with it. We have like radicals, so we're just going to add the two coefficients together. So this becomes 7 square root of 3. This second problem, same idea. We've got square root of 18, square root of 50 with their respective coefficients. Let's see if we can simplify these. I know this breaks apart into 9, and then you've got the square root of 2. Square root of 9 is 3, so we're going to take the 3 times the 6, which gives us 18, and we bring down the square root of 2. All right, so that's simplified. Then we'll look at the 50. We know this is going to be the square root of 25 and the square root of 2. So we've got 3 square root of 25 times the square root of 2. Well, square root of 25 is just 5, so 3 times 5 is 15, and we'll bring down the square root of 2. And so now we have like radicals, so we're going to bring those together. So this is going to be 33 square root of 2.